The broadcast is now starting. All attendees are in listen-only mode.
On behalf of RBCS and Software Test Professionals, welcome to today's webinar on test estimation. I am Rex Black, president of RBCS, a worldwide testing and quality assurance firm serving clients ranging from small startups to Fortune 20 global enterprises. Since 1994, we've offered insight and confidence to hundreds of clients around the world. We have a team of international consultants who deliver customized training, consulting, and outsourcing services to companies that are looking to improve their test and quality assurance practices. I am the author of 10 books on software testing, including the bestseller Managing the Testing Process, which is where today's webinar is sourced from. We are presenting this webinar in partnership with Software Test Professionals. You can check out their website at www.softwaretestpro.com. Attendance at today's webinar earns PMI PDUs. I would like to thank Ken Young for reviewing this material for PDU status and for making valuable suggestions. Attendees will receive an email telling them how to claim their PDUs. PDUs are available for live webinar attendance only. Before we start the presentation, a couple of notes. Feel free to submit questions through your webinar interface at any time throughout the presentation. But please note that I only answer those questions at the end. Also, there is no need to ask for presentation copies. The presentation is already on the web at rbcs-us.com. On the Basic Library, navigate to the Resources tab, and from there to the Basic Library page. Also, by attending this webinar, you are automatically registered for the free e-learning drawing. Check your email over the next couple days and watch the spam filter. Finally, a quick comment here. We have, up until about 10 minutes ago, experienced occasional internet connectivity dropouts, which were intermittent and of short duration. We believe that we have that problem fixed, but if not, we may be periodically interrupted. I will be able to see it if it happens, and I will pause the presentation while waiting for the connection to come back up. Generally, the connections have been down for 15 seconds or less. I hope you enjoy this free webinar from RBCS. We do these as a service to the software testing community because at RBCS, we are a not-just-for-profit company. As I said, today's webinar is on test estimation. So how many testers do you need? How many tests? How many bugs will you find? How long will the testing take? These are all the kinds of questions that we're trying to answer with test estimation, and I'm going to try to give you some ideas about that as we go through the course of today's talk. So, we're trying to create an estimate. It's first, whenever you're trying to do something, it's first a good idea to determine what exactly would constitute a successful outcome of what you're trying to do. So, what is a good estimate? Well, one which accurately predicts what's going to happen. Right? An estimate that says something's going to take 10 weeks and it actually takes 15 weeks is not a very good estimate. The estimate also needs to be fine-grained enough that we can actually follow along as we go and check to see whether there's any deviation from the estimate. Are things taking longer? Are things going more quickly? Have new issues popped up that are going to create delays? So that's the guiding of the project as well as predicting. A good estimate is realistic, which means that there's nothing missing from it. All the tasks that need to be carried out are there. Each task is accurately estimated. Each task's estimate has the same likelihood of being too little as the likelihood of being too much. In addition, any risks that could affect your ability to carry out the sequence of tasks according to the estimate have been identified, assessed in terms of their likelihood and impact, and appropriate steps taken to manage those risks. And also a good estimate is actionable. So actionable meaning that each task has an owner. That owner is committed to carrying out that task. The resources that are necessary to carry out the task beyond the person, the people are identified and assigned and actually available and committed to you. And any dependencies within the test schedule, the test estimate, or dependencies outside, in other words, like when we have to wait to receive working software, all of those dependencies have been identified. Now, how do we create an estimate? Well, there's three main types of activities, which I'm going to look at here as we go along. The old standby is to ask the experts, ask those who know, ask people who have done the work before, and ask the owners, ask the people who will do the work. Now, hopefully those are one and the same people. They're not, but they're not always. So we have to be a little careful about that. But want to make sure that we've identified people who know how long things take and the people who will be doing the work, and make sure that they are part of the process. This is part of obtaining their commitment. We also want to look at historical metrics from past projects and industry averages that are available to us, just to check to see, hey, does our estimate actually make sense? And also I'm going to show you how to use historical metrics as a way of doing some very useful prediction about things like how long it's going to take to find all the bugs and how many tests you're going to need. Now, a third important component here, which is not always understood or appreciated, I guess maybe is the right word, is the need to negotiate. It's unusual in my experience as a manager for me to go off, put together an estimate, come back and say, this is how long the testing is going to take, and have everybody go, oh, okay. Usually there's more back and forth that has to happen. And it's important that in doing that, you don't damage the good qualities of the estimate that I was discussing a moment ago, the accuracy, the realism, the actionableness, if that's a word. Because there's plenty of times when people create good estimates initially, they go to management. Management goes, no way, do it in half as much time with half as many people. And people just go, oh, okay. And then they commit to doing everything that was on the original estimate for half of what they actually needed, or, well, this is really more like a quarter of what they needed. Then, surprise, surprise, that's a completely unrealistic, worthless estimate. So in order to avoid that kind of thing, you need to be ready to negotiate. And we're going to talk about how you might do that. Now, let's start with making sure that we actually can get to a successful conclusion of this estimation process. One of the things that we have to understand is what are manager and stakeholder expectations of what they want us to do from a testing point of view. Now, there are 4 expectations that they could hold, 3 of which are achievable, and as long as a consensus exists amongst all the stakeholders and managers of which of the 3 are to be achieved, then an estimate can be successfully put into place. The 4th is completely unachievable and represents a much more serious political problem within the organization, or expectation problem within the organization, that no amount of good estimation skills are going to fix. So let's go through these expectations, the ones that are okay, livable, achievable, and the one that is impossible. Okay, so in testing, there is this concept of the test basis. And the test basis is just whatever you're going to base your tests on, whatever it is you're setting out to cover. Now, all too often when I say whatever you're setting out to cover, people immediately go, aha, that means requirements. No, that means requirements in part, but it also means other things. Supported configurations, quality risks, user personas. You can easily, in most organizations, identify a good 4 or 5 different dimensions of coverage that might very well be appropriate. I did an entire webinar on dimensions of test coverage, so I'm not going to repeat myself. I would encourage you, if you're like, well, I really never thought that the test basis would be anything other than a set of requirement specifications, go take a listen to the recorded version of the webinar Dimensions of Test Coverage, which is out on the RBCS website. Go to the Resources tab, and then from there to the digital library, and you'll find it. So we're going to test something. That's the test basis. And the 3 different achievable expectations regarding that the extent of coverage we're going to achieve are the following. First is that you are going to cover the test basis completely, whatever completely means, whatever doing all of the tests that would need to be done for everybody to sit back and go, yes, that has been thoroughly tested. You're going to do that, and nobody cares how much that costs or how long it takes. Now, of course, there's a practical reality. Oh, somebody always cares, but the expectation is you're just going to do that. Now, you might think that's weird. Does that actually ever happen? Oh, sure. I mean, we have clients that are in the FDA regulated world where what has to be tested just simply has to be tested, and the evidence that you tested it and that those tests passed has to be collected, and whatever it costs to do that and however long it takes to do that that's how long it takes and that's how much it costs, because otherwise you can't ship. Because if you get audited and are determined to not be in compliance with the FDA regulations, then whatever it is that you've got, you're not shipping it. Now, some of our clients I've worked with operate with a somewhat constrained set of expectations, which is do as much testing as you possibly can, and we're not too worried about money, but you have to be done on a particular date. So I've worked with a few projects where we had these kinds of, we're willing to throw money at the problem, and we're willing to do a lot of testing between now and the delivery date, but the delivery date is the delivery date. You have to be done by date X. Also, you can live with that. It's just a matter of going, well, what can get done by a particular date, and how much extra testing could get added if we threw more money at it. Now, then there's the third assumption, which is the third expectation, which is the one that I think most projects live in, which is that people want you to cover the test basis as completely as you can, do as much testing as you can, but there are schedule constraints. There is some sort of deadline, and usually there's kind of a soft deadline where everybody'd like to be done, and then there's the hard deadline where, this project ain't over by then, it's dead, right? And there's also cost constraints. And again, there's usually a soft and a hard constraint, right? There's the money that you get initially, and then there's the money that might become available later when things get a little more critical, and people get a little more willing to say throw money at a problem to try to make it go away. Usually there's some kind of withholding of some amount of I could say slush, because that's a pejorative word, but some reserves in case of a problem, and some of that might get thrown at testing if it were determined that was what you needed. But usually when people are asking you to work within schedule and cost constraints, they're asking you to work within the soft constraints. But do what you can to find out what the hard constraints are, just so that you know what's going to happen if the schedule breaks. So anyway, you can do any of those. You can live in any of those first 3 worlds without too much difficulty. It's just a matter of making sure that your head is in the same place as everybody else's. It's the 4th world that won't work, and this is what's called breaking the iron triangle, which is where people forget that there is within a project an interaction of how long a project takes, how much it costs, what features are to be created, and thus the level of quality that will be delivered. So the iron box and triangle here, the way to think about this is as follows. Now, some people talk about the iron triangle, but I think that leaves out something important, so I prefer to use this metaphor of the iron box and triangle. So usually what happens in the initiation of a project is that there's a set of features that are defined. Now, that might change over time. Of course, if you're working in an agile environment, that will change over time, but there is some sort of initial idea that this is what we want to build. And of course, that's the first thing, because without some desire to build something, there's no project. So next, what happens usually is that there is some idea of this is when we'd like it to be done. Now, of course, in Agile, again, this works a little differently than with sequential. With a sequential project, the delivery date is bang, it's at the end, and, that's when we're not going to have anything until then. The pressure is relieved somewhat in Agile through the periodic delivery of working software, assuming that happens. But still, there is generally this idea of we would like to be done by a particular date. And a number of our clients that are using Agile actually still have the same kind of constraint. When, for example, you're building software for enterprise situations, like one of our clients builds software that helps telecom companies do their billing. And there has to be a commitment that a certain set of features is going to be done by a certain date. And there can be a little bit of wiggling around in that, but not a lot. So the schedule is set. Now we have a delivery date. And a metaphorical way of thinking about that is that imagine drawing a line from one side of the box to the other, just to another side, an adjacent side. That's now a constraint, right? And generally what comes afterwards from that is, okay, well, this is how much money we've got. So money is allocated. And so now that's been fixed, okay? The thing that people forget is that if you constrain feature, schedule, and cost, you're going to get whatever quality your software engineering process is capable of delivering. Done. That's what's going to come out of the end. It's done. I mean, it doesn't matter. You have already determined the level of quality that you're going to produce. Now, yes, over time, you can improve your software engineering process, including your test process, and achieve a higher level of quality even when constrained by schedule and cost. But, assuming that that's just going to magically happen from one project to the next without a major effort to identify where the software engineering process needs improvements and make improvements is not connected to reality. Unfortunately, organizations do this over and over again, where they go off and they define the features, set the schedule, set the cost, set the budget, and then they're shocked when there are problems at the end, quality problems at the end, just like there were before, right? So, you need to understand, and you need to help other people understand that if the schedule and the cost are constrained for a given set of features, then you're going to produce the same level of quality that you produced last time. And that's just it. And if everybody's okay with that, that's cool. Then you're back to scenario 3 here, cover the test basis as completely as possible within schedule and cost constraints. But if people are saying unrealistic things like, well, no, you're only going to get this long, you're only going to have this much money, but we want you to find 99% of the bugs this time instead of the 85% that you found last time. Again, that is not connected to reality, and there's really a fundamental problem that has to be solved before there's even any point of doing an estimate, because whatever you come up with is not going to be successful. So make sure that you've dealt with that problem if it exists. Okay, so now creating your estimate. Well, the starting point a lot of times for estimates is to create a work breakdown structure. Now, work breakdown structures are more widely used in sequential lifecycle models than in Agile, though we still see clients using them in Agile, at least to identify which teams are doing what. So they are useful even in that context. But let's assume for a moment you're doing a sequential lifecycle model. Basically, what you're going to have in terms of testing is a hierarchical decomposition of the testing work to be done. That's your work breakdown structure. And one way of doing this is to say, well, there's planning work, there's staffing work, there's setting up the environment, there's developing the test, and there's executing the tests. You can also, if you prefer, use the ISTQB fundamental test process as the major stages. It really doesn't matter. You just need to have some sort of framework that allows you to kind of look out and go, okay, this is at a high level the kind of stuff that's going to be going on. And then, as I said, there's a hierarchical decomposition of the work to be done, so you're going to start to decompose those stages down to activities and then down to discrete tasks within each activity. Now, what constitutes a discrete task? Well, as a general rule, you want them to be short. 1 to 2 days long is a common rule of thumb. And the saying you sometimes hear about this is that you want, in your schedule, you need inch pebbles as well as milestones. You want to get it fine-grained enough that if something goes wrong, you will see it very quickly as you monitor your progress. Another good rule of thumb for tasks is that they should have a single owner. So if a task has multiple owners, it's often a good idea to try to decompose it further or to identify the primary owner and as distinct from, say, a secondary owner, a person who's helping. And this is kind of the I hesitate to use this metaphor because I find it somewhat childish and it doesn't translate real well culturally, but this is sort of that pigs and chickens thing that you hear about in Scrum. This just differentiation between who's actually doing the work versus who's just a stakeholder in the work. Whatever it takes, get it down to having a single owner, ideally. And also, ideally, there is a work product which is produced by the task. That work product is something that can be inspected, reviewed, tested, whatever, to determine, yes, indeed, this does meet quality standards. Those of you working in an agile world, you'll familiar with this phrase, the definition of done. There has to be some way of saying, yes, this is done. Now, how do you go about identifying these tasks? Well, I like to apply 2 techniques here. One is something I refer to as thinking forward, and the other I refer to as thinking backward. So thinking forward is, you're in the inception of the project. This is initial planning. Now, this is probably not your first rodeo. You've probably been through a few of these before. So thinking forward means sit back and think about what you typically do on a project. What happens first, what happens second, what happens third, et cetera, et cetera. Just using your memory of what happens on projects, think through the process. Okay, and that's thinking forward. Now, thinking backward, as distinct from backwards thinking backward is sit down and think about what you need to test. Okay, remember your test basis I mentioned? Reflect on your test basis. Okay, think about critical risks to quality that have been identified if you've done a risk analysis. And say, okay, so that tells me what tests I need to run. So those are the test suites that are going to be in your test execution period. Now, backing up from that, go, okay, how many of those actually exist already, or how many have to be developed? And by the tests existing here, I'm not just referring to the test cases themselves. I'm, of course, referring to any sort of automated support for those. I'm referring to data. Any sort of element of the test, what if that exists? And if it does exist, what kind of updates need to be done to it, and how long will those take? If they don't exist, then you need to ask yourself, okay, well, how long is it going to take to create those? Ask yourself whether you have all the environments that you need, and are they properly configured? If the answer is no, we don't have that environment, then how long is it going to take to acquire it and configure it? If the answer is yes, we have the environment, but it's not set up right, okay, well, what's the configuration effort required? Do you have all the people you need? There might be staffing work that needs to be done. So, for example, if you know that you need to do a performance test because performance has been identified as a key risk, but nobody in your team knows how to do performance testing, okay, well, maybe you need to bring in a consultant to help with that, or hire somebody, And then planning. How long is it going to take you to go through the various activities in the planning process? Again, if there's performance testing required, maybe you as a test manager don't know enough about performance testing to really come up with a performance test plan, so you're going to try to find someone to help you with that. Again, bringing in a consultant. Okay, so that's what I mean by thinking backward. So what I usually find is that by thinking forward and by thinking backward, I can come up with a good 80 to 90% of the tasks in the work breakdown structure as a test manager. At which point it's time to go to the team. Now, what I'm going to do is I'm going to have the team review the estimate, and in the course of that process, I'm going to ideally identify any missing tasks. Now, I might have some ideas about how long things are going to take. I can discuss those with the team, and we can come to an agreement on those. Or we can apply something which is called the Delphic Oracle technique. If you are working on Agile projects, you'll be familiar with this as what's called planning poker. It's just a new name for a technique that's been around for a long time. And in the Delphic Oracle technique, what you do is you ask each member of the team to estimate how long it's going to take to carry out each task. But the thing is that you don't do that verbally. You have them write down on a piece of paper, which they do not show, what their estimate is. And then there's a reveal of that during this meeting, this discussion. So once everybody has estimated, okay, go around the room, what's your estimate? All right. Now, what can happen is that there can be a high estimator and a low estimator. If so, then you ask the high and the low estimator to explain their estimates, and you go through this process again. If everybody agrees, either the first time or the second time, or even the third time, then you're done. If you repeat this process twice and you don't get agreement, then there are various ways of breaking the tie. Some people will say use the average. That was the original Delphic Oracle technique. Some people in the Agile world will advocate using the mode or median value. Hopefully the estimates are close enough that using the average versus the mode versus the median is not going to result in a huge difference in terms of what your estimate is. Now, there is another technique which is sometimes used for estimation, and this is especially useful if you're looking at tasks that are on the critical path. It's what's called the three-point technique. The three-point technique, people don't just estimate one value, which is the expected case. They actually estimate three. They say, yeah, there's the expected case, there's the best case, which is everything goes really well, and there's the worst case, which is everything goes poorly. Now, you're going to use the expected case as the publicly disseminated, published estimate. But you're also going to use the best and the worst case privately to get a feel for the accuracy of your estimate. The wider the variance between them, in other words, if the best case is will be done in 3 months aggregate across all of the tasks, worst case is 9 months. Okay, you've got a lot of uncertainty in your estimate. Now, another thing to do there is to identify the enablers of the best case outcomes and the causes of the worst case outcomes. And of course, you want to, the causes of the worst case outcomes are risks. So you go, okay, I need to manage those risks. The enablers of the best case outcomes are things you're going to try to have in place so that you can get some acceleration. Now, in addition to understanding the duration of the tasks, it's also very important to understand the dependencies. Now, a process that will allow you to assign the dependencies is to first go through, look at your tasks, and identify the tasks that have no predecessors. In other words, they have no dependencies. Nothing has to be done first before those tasks can start. They can start right away. Then you go through and you say, okay, which tasks depend on those tasks that I've just identified as the zero predecessor tasks? So now you're going to come up with a set of tasks which depend only on the tasks which have no predecessors. And then you say, okay, and which tasks depend on those tasks, so forth and so forth. You repeat that until all the dependencies have been identified for all of the tasks. Now, if you're working on a very small project, or if you're talking about an agile project, you're talking about one single iteration, this can be done within a task management tool or a project management tool. I've done this in MS Project for small projects before. If you're talking about a medium to large project, then this will often overwhelm the scope of these tools. Ways to do this, to deal with this, is to use index cards or Post-it notes and a whiteboard. I actually had one client tell me about taking butcher paper or big flip chart paper and hanging it up all around the 4 walls of a very large conference room. Well, very large, like 100-person size conference room, and putting a timeline on that and going through and putting all of the tasks up and showing the dependencies between them. They had this enormous Gantt chart wrapped all the way around the room, and this was for a 2-year-long integration project where they were going to take all of these applications that were in these different systems that were sort of, legacy is the wrong word. This was a company that had grown by acquisition, and they had all these systems that were all kind of standalone, and they were going to try to integrate them all together, eliminate ones they didn't need anymore, and have automated data integration with the ones they did need. So this was the project, and there were a couple hundred applications involved. So big project, and the technique worked fine for them for that. So as you're doing this, what you're trying to do, part of what you're trying to do, is to figure out how long the project is going to take. But the other thing that you're trying to do is figure out why the project is going to take as long as it's going to take, and that's what's called the critical path. So the critical path is this sequence of dependent tasks where if any task in that sequence slips, that will necessarily delay the end of the project by an equal number of days. You also want to look for what's called near critical path, which are dependency sequences where a task could slip by a day or two and things would be okay, but if it slipped by, say, a week or more, then there'd be a problem. Another thing that you want to look at is, to the extent that there are project gates, entry and exit criteria, those kinds of things, make sure that you've identified those, because what tends to happen there is that those entry criteria are effectively dependency points where every task that comes afterwards in the project is dependent on satisfaction of that entry criteria, and similarly with exit criteria. So want to look at that. Now, you also want to look at test execution and how many tests are we going to have to run, how many cycles we're going to have to go through, and so forth. That's something I'm going to discuss shortly. Another thing to do when you're doing a test estimate is to make sure that you've looked at any sort of external dependencies. This can be a real cause of problems in testing. It happens very frequently. So, what teams are you dependent on? Again, have you communicated with those people about the dependencies that you have? Do they understand the support you're needing from them, etc.? Another thing that has to happen as part of the estimation process is the assignment of resources. So you have to figure out, who's going to do the work in your team, and make sure that you have selected the appropriate people. In the Mythical Man Month, Fred Brooks makes the point that since what we're doing is brain work, it's going to be a significant problem if we just assume, well, people are people and we can interchange them and, no issue with that. The more people we throw at the problem, the faster it will get solved. And that's not true. In fact, Tom DeMarco and Tim Lister in their book Peopleware have identified a phenomenon through a number of sort of gaming exercises that they've done, which is that the most qualified person and the least qualified person tend to differ by a factor of 10 in terms of their effectiveness. So what this means is if you assign the most qualified person to a task, it's going to get done a whole lot faster and a whole lot better than if you assign the least qualified person. So, something to be careful of. If you're in a situation where you're like, well, I'd like Joanne to do this because she knows this the best, but the only person I have available is John. He doesn't really know it that well, and I think he's competent to do it. Well, you're going to need to adjust the duration based on that. Make sure that you talk to John about how long he thinks it's going to take him to do it. Also, another thing to keep in mind is what if you are dealing with some tasks where nobody really knows how to do it, or they haven't used the tool that's going to be used. They've done it before, like say they've done performance testing before, but the last time they did it, they used the IBM tool, and this time they're going to be asked to use the HP tool. Okay, guess what? They may have given you an estimate for how long things are going to take, but do they really know? So take that into account. Your test environments. Make sure that you have thought through what you need with respect to environments and that those have been assigned to tasks. Usually it's not a big deal if there are some minor omissions here, like, generally people don't have to get down to pointing out how many pens they're going to need. Though I had one client tell me that they were kind of half joking about it, but I think more serious than not. Oh, no, we do have to know how many pens we're going to need. Apparently they have to account for everything. So what I've typically found is that it's the expensive stuff and it's the long lead time stuff that you really have to be careful about. If it's going to cost a lot of money or it's going to take a long time to get installed, then definitely don't forget it. Also, your tools. Now, open source is a little bit less of an issue because there's no acquisition cost. But even with open source, there are various non-recurring costs associated with getting it set up and installed and everything. So that needs to be part of your estimate. Definitely, if there's going to be any custom tool development, that absolutely has to be part of your estimate. And it's certainly commercial off-the-shelf tools. Especially if you're dealing with something where there could be licensing issues. Make sure that you have thought through carefully how many licenses you're going to need. And I'm not just talking about test automation tools here, though obviously that's a big part of it. I've seen this be an issue with bug tracking tools too, where there were insufficient licenses and people were not able to enter bug reports when they found bugs, and information was queuing up in people's notebooks, and then they were having to enter it later, and it was a real mess. There's the source of the title of the book, The Mythical Man Month, is the assumption that you can get the work done in half the time if you assign 2 people. That is, of course, not accurate. Make sure that you keep that in mind. It might be possible to accelerate by adding more people, but often as not, it won't. The source of the phrase "Mythical Man Month" is exactly that. Be careful about putting too many people in an environment, or trying to use tools in a way that is unsustainable. That can be a real problem. Again, as I mentioned, I've seen that come up as an issue. And also the environments and the tools will need to be set up, and they will need to be supported. So who's doing that? How long is it going to take? Are those people committed, etc.? Okay, so test execution. Let's talk about test execution a little bit now. So far I've been talking about using primarily a human-driven estimation approach, where we're talking to people about how long things will take, and we're relying on their judgment and their experience. Where I find that that approach tends to break down is when it comes to trying to predict how long it's going to take to get done with test execution. This is actually a 2-part question. People get confused about this. If you ask somebody how long it's going to take to get done executing the tests, you have to figure out how long it's going to take to run all of the planned tests once. So how many people do you have to run the tests? How much estimated test time is there? How much time can the testers actually spend running tests each week as opposed to doing other things like reading email and attending meetings and so forth? Okay, so you'd say, all right, well, if I'll figure out how long it takes to run every test once, and that's it, right? Well, no, because that's an example of a common testing worst practice, which is to plan testing on the assumption that you won't find any bugs. Typically will find bugs. And when you find bugs, that means we're going to be in a situation where those bugs need to be fixed, and you're going to have to do a confirmation test of the bug fixes when they finally show up, and there might be some time waiting for the bug fixes to show up. So we need to understand how many bugs, how long to fix, what's that going to do to our test execution period. So the best approach for this that I've seen over the years is to use historical data from similar past projects to try to predict these kinds of things. So let's look at these 2 parts of the puzzle. How long is it going to take you to run the tests? Now, you need to understand what's your mix of scripted versus exploratory testing, manual versus automated testing. How are you handling regression testing? You're going to repeat all the tests, some of the tests. What's your plan on that? You need to also think about the fact that testers during test execution are not going to be able to spend 100% of their time executing tests. They are going to go to meetings, as I said. They're going to have time spent doing email. They're going to probably have to review each other's bugs and tests. So general rule is, understand what your what's called time on task is, what percentage of time people are able to spend during test execution, in this case, actually running tests. Again, look at historical averages for this, and use those numbers to do your prediction. Now, in terms of how many tests are you going to have, what you'll want to do is go back and look at, for past projects, how many tests you had, and look at things like, the number of requirements, the number of risks, other test basis elements, and what's the correlation between those and the number of tests that you've had in the past. There might be some formula that you can come up with that if you plug it in, then, this many requirements and this many risks and this many configurations and so forth gives you this many tests. Doesn't have to be completely accurate, but, you want it within, say, plus minus 20%. You'll also want to look at historical data about how long each test takes to develop, how long each test takes to execute, in particular, since we're looking at execution here. How many person days of testing are available in a week based on the time on task for the testers, etc. This is going to allow you to predict how long it will take to run the tests. One thing that can be useful is to have some sort of graphical model of how your testing is going to work, like what you see here on slide 11. That will allow you to get a sort of a mental picture of what fits in where, how the process is going to work. This is a sequential life cycle model. You could do something similar to this, mapping out the test execution period for an Agile project. Of course, you're not going to be waiting until you're feature complete to start your testing on an Agile project typically. But have an idea of how things are going to work. It can be, without this kind of mental model, this picture, and it doesn't have to be fancy. You don't have to Visio it like this thing is. You can just, draw this on a whiteboard or something like that. But, what does our test execution period look like? What's happening? What are the major activities there? And try to figure out how long is it going to take me to get to done for a single pass of testing. By pass, I mean one complete run through my tests. Which then brings us to the next question, which is that question of how long is it going to take to get all the bugs out. Now, I mentioned using historical data to predict the number of tests, and you can basically do the same thing here with predicting the total number of bugs. What you're going to do is pick a parameter that you think will be a reliable way of predicting the number of bugs that you would get. Now, this is basically what's the size of your program. Some organizations use function points to do this, though most of our clients cannot. They don't have reliable function point counts available to them. Some clients use size in terms of source lines of code, or thousands of source lines of code, case locks sometimes called. You have to be careful with lines of code as a size metric, because if you're using multiple languages, you're adding together numbers that are not in the same units effectively. So you have to come up with a way of converting them to a common size. What you can do is use what's called backfiring, which is a function point technique that allows you to convert source lines of code into function points, and there are these conversion factors that are available for pretty much every language that's out there. So you can try to come up with a set of function points through the lines of code. But the easier way to do it is just to look at the number of bugs per developer day. So let's say I go back, I look at say 20 past projects, and I find that on average there were 5 bugs introduced per developer day. Now, by developer day here, what I'm talking about is I count up the total number of developers on the project and the total number of days each one of those developers worked, and that summed up gives me the number of developer days. Now, it's probably better to also include in that count any business analysts or and other parties who are writing, creating work products in which bugs can be introduced. So I come up with the total number of developer days, the total number of bugs. By that, I'm able to come up with an average bugs per developer day. Now, by going to the development manager or project manager, I can get an estimate of the number of developer days for this project. And by using that together with the historical average of bugs per developer days, I can predict the number of bugs I think I'm going to find. Now, excuse me, this is, of course, seems kind of like magic, but this actually does work. We've got clients that do this to good degree of accuracy, like plus or minus 10%. So it does work. You do have to keep in mind that there are things that will change it. So, if the life cycle is different than in past projects, if the team is somewhat different than in past projects, you're using new technologies and so forth, that can all have an influence and make this considerably less predictable. Now, graphically here, this is what you're trying to get to. And this, you can download this spreadsheet. It's on the RBCS website. Believe it is on the basic library. Might be on the advanced library. One of the two. It's under test estimation, so you can find it and download it. It's free to a good home, as they say about puppies and kittens. But also, as is usually the role with an adopted puppy or kitten, there's no ongoing support. So if you download it and use it, that's cool. Good for you. I hope you find it useful. If you want some help with using it, well, we're happy to do that, but that's where this goes from free to costing money. But anyway, you can download this if you want to see how this works. But basically what we've done, we've predicted that there are going to be 300 bugs. And by looking at historical data, maybe the historical data tells us that half of the total bugs remaining to be found will be found in each week of testing. So the first week we find 150, right, because there are 300 bugs remaining to be found. The second week we find an additional 75. The week after that we find 38. The week after that we find 14. And it just kind of converges there. Again, you need to look at your past data and see what shape your bug find curve has. And then you can look at how long it takes to fix bugs. Now, one way to do it is using the model that is in the spreadsheet that you can download. In this spreadsheet, what it does is it looks at what percentage of bugs are fixed in the next release received versus the percentage that are fixed in the release after that versus the percentage that are fixed in the release after that, and so forth. So that's one way to do it. Another way to do it, which is a little simpler, is to look at what the average closure period is for past projects. And the closure period for any given bug is just the time from the date on which it was opened to the date on which it was closed. You take the date when it was closed, subtract the date that it was open. That's the number of calendar days that it was open. That's its closure period. Add that up across all of the bugs on the past project, divide it by the total number of bugs, and that'll give you the average closure period. So if you know that the average closure period is 10, from 10 days, then you can just make a simplifying assumption that 10 days after the last bug is found, we will be done confirming that bug as fixed, and that's when we're going to end. Now, it's a little more complicated than that because you have to, it's best to do a trend chart of the closure period over time and make sure that the closure period is stable, that it doesn't tend to go up at the end, which sometimes you see, so that could be a confounding factor here. But, again, what you're trying to do is to come up with an estimate here. The more data you can throw at this, the better, of course, especially if this is a large, long, critical project. For smaller, simpler projects, you want to be able to come up with the estimate quickly. You don't want to spend, 2 weeks working on an estimate for a project that's only going to last about 2 months. Okay, so people tell me this all the time, that test estimation is one of the most difficult parts of their project as test managers, and it's really one of the most difficult parts of software estimation because of the whole test execution piece. And the numbers bear it out. We have over 300 people on this webinar. This is the third time I have run this test estimation webinar, and it typically does attract exactly that number of attendees or more. In fact, the first time we ran it, we had 1,000 registrants. So there's a lot of interest in this. People struggle with it. There's human issues involved, human factors involved, like the expectation issue that we were talking about up front. There's best practices of project management involved. That's also an important piece. There's use of historical data for estimation involved, and that's something that people sometimes struggle with, and it takes them a while to learn. So it's a challenge, but it's one to be taken very seriously. I did a webinar. I believe I did a webinar on this on interviewing, or maybe that's in the future. I did a presentation on it. Maybe the webinar is coming up, but interviewing is similar. It's really hard, though, of course, for completely different reasons. And because it's really hard, people are kind of tempted to go, well, this is really hard, and I'm just going to kind of give it my best shot and see what happens. Well, no, you don't want to do that, because, unlike sort of a haphazardly made breakfast, doing your test estimate improperly or hiring the wrong people due to bad interviewing will have really serious long-term consequences. So as challenging as these things are, and as multidimensional as these things are, you do need to invest the time to master these techniques. The establishing the common expectations, the best practices of estimation, project management skills related to that, the creation of these parametric estimation models using historical data. All of these are essential skills that a test manager needs to have. When you learn to apply them, you will find that you will get good at this. One of the things that I've done on a number of occasions in my career is I've had to give fixed bid estimates, fixed bid projections in contracts, based on estimates of, okay, we're going to spend this much and we'll commit to do it for this amount of money. So I'll tell you, if you want to get good at estimation, that's one way to force yourself to get good. Is if you overcommit, guess what? It's your money that it's coming out of. So hopefully you don't have to take that extreme route to do it. Just keep practicing, applying these techniques, learning more and more about the process, and make sure you're getting better with each passing project. All right, so as usual, I will go to the advertisement here and go to the Q&A panel. So if you haven't already submitted your questions, please go ahead and do so. Abhishek asks, my phone doesn't have an option to mute myself. Is there some option in the webinar to mute my line? Everybody is automatically muted. That's the way these webinars work. I can unmute people. The reason I don't unmute and have this be audio Q&A is because well, if you've ever been on a conference call with a lot of people, you know the answer to that. It's chaotic would be an understatement. Tom says, in regards to negotiating the testing estimate with other leaders, I agree that program managers always ask us to sharpen your pencil. We try to develop the most accurate estimates in the beginning of the process, so would you recommend that we build in extra contingency to account for the inevitable negotiating? Now, by sharpen your pencil, I think what you're referring to is this pushback going, do the same job with less time and less resource. In other words, do it better than you did it last time. And I understand, Tom, the temptation to build in contingency And I think there is actually a good case to be made for having contingency in your estimates, because you're probably going to need it. I think there's a real problem though with building in contingency with this sort of, I know this is going to be taken away from me, and hiding the contingency. This is a real bone of contention. I remember being in a conference, I don't know, a couple years ago, where somebody came up and made that statement of, yeah, just build in a bunch of contingency into your tasks and hide it, make it so that no one can see it. And then when you get that pushback and then, sharpen your pencil, then you can just go, oh, okay, and you cut the time out. And the problem with that is I think that one of the reasons you get asked this sharpen your pencil or do more with less is that everybody thinks that everybody plays that game, that hidden contingency is in there. And so I'm going to push back and, try to get a cut and because I'm going to cut that extra out. And the problem, it makes this a zero-sum game. That, you're trying to hide something as an adversary who is trying to force what you're trying to hide out into the open. Personally, I think that's just no way to run a railroad. Now, I understand there are cultural things here where, I remember being in a negotiation with a guy once, and I'm not going to get into the country where this was because it doesn't matter. But basically, he was pushing back on the price. I'm like, no, that the price is what it is. Okay, we don't quote inflated prices, and then on the assumption that we're going to cut those back. I mean, we charge the same. Everybody pays the same price. This is how much I charge for this job. And he said, well, you have to understand that as a purchasing manager, if I can't get a discount, my bosses are going to look at me and think I'm incompetent, or that I'm in cahoots with you and that you're getting me a kickback. I'm like, well, I can't do anything about your problem there. I mean, are you asking me to the next time I want to do business with you to take my usual price that I would charge everybody else, add 25% to it, and then go to you? That was sort of what he was asking me to do. I mean, I just don't think that that's very desirable. Now, of course, I'm in a different situation than you are, Tom, in the sense that as a consultant, I get to choose what work I take on and what work I walk away from. And if the process of negotiating the contract to get the work becomes sufficiently odious to me, then, like it did in that case, then I just walk away from it and just go, well, I guess I'm not doing it. If you've got a job that you like and you want to keep, there are probably, that's probably like, I like most of it, right? There's probably a good 10 to 20% of that goes along with being in that particular company, this particular industry, et cetera, that you don't necessarily like. So, this might be the part that you don't necessarily like, and this might be the thing that you have to do. You have to play this, this is a harsh word, but deceitful game with your manager, hide the contingency game, and see how much you can hide. Personally, I would prefer to just push that entire negotiation into the open and say, look, if you cut this back, then here's what you cut my money back. You tell me which tests you want me to do less of. Let's go through the areas that I'm going to test. You tell me what you want me to test less than I'm currently testing. I'll cut that testing back, and then that's what we'll do. So I'm not saying don't refuse to negotiate, but I'm just saying, don't having hidden slack in there. I personally don't like it. Jeremy Corbin asks, where do you find industry averages for estimates? Capers Jones's books, estimating software costs especially. Mercedes says, in reference to the assigning resources slide, my personal favorite to use is 9 women can't have a baby in 1 month. That is absolutely true. I've been on plenty of projects where that was tried. Diana reported that they lost audio at 1:49 p.m. Central Time. I'm thinking that was probably your connection, Diana, not everybody's, because what I will see when, or not your connection rather than mine, excuse me, because what I'll see when my connection drops and then comes back up is that everybody submits a comment saying they lost audio. And in this case, it was just you, so I think you just had a connectivity glitch. But thank you for letting me know, because it could have been the start of, a problem. And I do appreciate when you have these audio dropouts or other kinds of glitches, do let me know, because certainly this GoToWebinar software is not without its hiccups. And by letting us know about these things during the Q&A session, it really helps us hold Citrix's feet to the fire on this stuff. Antonio asks, what are your preferred strategies or techniques for test estimation in a crowdsourcing environment with a small on-site team? Well, crowdsourcing, effectively what you are doing is you've got some sort of beta test, though often a more structured form of beta test going on. Now, when you reference the small on-site team, so there's some amount of actual professional testers involved. I mean, the thing that you're going to want to look at is, from historical experience, what percentage of the bugs are found by the crowdsource organization or people. That might be a very large percentage. But then also make sure you look at the noise rates. Usually what happens in beta testing is that there's a lot of noise in the bug reports coming in. So, look at the level of noise historically, figure out, okay, how long do those take, what amount of to get fixed, those bugs that are found by the crowdsourcing people, how long do those bugs take to get fixed. How much regression testing is associated with the system when those bugs get fixed? Who does that? That's your team. That's going to have some load implications. So basically what you're doing is you've got to build into your historical modeling for test execution some way of dealing with this stream of bugs that's coming in from this external source. Bernard, good to see you, Bernard. How are things in France, mon frere? On slide 11, you suggest 2 cycles per pass. Whenever a bug fix is delivered, shouldn't one do a regression test and a retest or confirmation test? In this case, that seems to imply reinstallation of the test environment and regression plus retesting. Yeah, so if we go back to this page, let me... that one. Yeah. So what's happening here is we're doing 3 passes of testing. Pass 1, pass 2, pass 3. Now, those can either be the same tests, and they would be if you're doing if you're planning on a complete re-execution of your test for regression testing, or each pass can be primarily a different set of tests with some amount of regression testing built into it. Now, if you're going to do that second approach, where each pass consists primarily of a separate, distinct set of tests, then what you should probably do is adding to this model. You see, it says there's confirmation testing at the beginning of each cycle. And then there's the scheduled, manual, and automated tests, and then there's exploratory tests at the end of each cycle. What you could do is add regression testing. Now, that would not be in the first cycle, but it would be in cycles 2 through 6, right? So you'd be adding some time for regression testing. Now, you won't need that if pass 1, pass 2, and pass 3 are the same set of tests, right? So if you're going to run the same set of tests 3 times, since you're going to run that set of tests again, the same set of tests you ran in pass 1 will be run again in pass 3, then you're not really going to have to reserve any time for regression testing except for possibly in cycle 6. You might want to go back and select a small number of tests to repeat based on whatever bugs were fixed between release 5 and the golden candidate test release. Okay, so another question from Bernard here. It says, on slide 13, you are using some kind of Weibull curve, isn't it? Well, let's see. I don't remember the exact statistical name for this. Basically, what the arrival rate, which is the red line, the cumulative arrival, is basically each week I find half of the bugs that remain to be found. So there are 300 bugs planned or expected. So in the first week I find 150 because that's half of what remains. Then the next week I'm going to find 75 because that's half of 150 because 150 is what remains. So now I've found 225 bugs, and so 75 bugs remain. So I'm going to find half of 75, which would be 38. And so now I'm down to whatever, 38 left, right? And so I'm going to find half of that each time. So I don't remember what the name is for that kind of curve. It's kind of a hypothetical because you just have to look at historical data and then just do curve fitting on that. Excel will do a reasonably good job of letting you figure this out. Remember, what you're trying to do is not necessarily predict exactly what's going to be going on each week, but you want to have a reasonably good prediction of how long it's going to take to find the bugs and how long it will take to get them all fixed. There's another question from Bernard here. When using average closure period of defect, do you need to only count the fixed defects, or do you need to add deferred or canceled defects? Well, I mean, you can try to filter out the deferreds and canceleds. I usually don't because I like to show the closure period as a trend over time. And if you include deferred and canceled in that, what will happen is that if you see if there's a spike in deferral or cancellation, that will tend to show up as a dip in the closure period. So it's kind of warning sign. Now, of course, you can also just you can filter them out, and then you have a separate report where you look at on a week-by-week basis how many bugs were actually fixed and confirmed as fixed that week, how many were deferred that week, how many were canceled that week. So there's a number of ways to approach that problem, but you definitely will need to have some warning indicators of, do we have a problem? Let's see. Let me go here and just go back to the ad. Bob says, do you have suggestions on how to deal with management teams that have a habit of trying to break the iron triangle? Well, so, there's this gets back to something that's it's an old management concept called Theory X and Theory Y. So Theory X management says that people are inherently lazy and will do as little as possible unless they are pressured, cajoled, pushed to work harder. And so Theory Y says, no, actually, people are motivated to do their best work and will get things done with high quality as quickly as they can, provided that management gives them what they need to do their job and gets the hell out of their way. Theory Y management is sort of a foundational piece, by the way, of the whole one of the concepts of Agile, which is this idea of the self-directed team. You don't need someone in there bossing you around. You just need to get the stuff that you need to get your job done, and then everybody needs to get out of your way. That said, Theory X, the Theory X management mentality is deeply ingrained in a lot of organizations. If you're dealing with that, if you're dealing with managers who are fundamentally Theory X people, they might be perfectly nice people, but they've just, for whatever reason, come to this belief that if you don't push people, you don't get everything out of them that you can. Then you're going to be in this game of managers pushing you to break the iron triangle all the time, and I don't know how you can fix that. I mean, you could try to scrape together some money to have some famous management consultant, like say, Tom DeMarco, come in and yell at him about it, which he would. But this is you're talking about something that's effectively ingrained in someone's personality at that point, and it's going to be very very difficult. What you can try to do is refute with fact, and just say, look, I mean, this is what happens every time we do this. This is the result we get. Just so that you're not slipping into that mindset that I was talking about earlier, which Tom brought up, of that sort of the hide the contingency thing that goes on. That's the way a lot of people respond to it. And of course that just reinforces the idea, the Theory X idea, that see, if I hadn't pushed them to cut that waste in there, that they would have just malingered and burned that time up playing video games, right? Or what have you. So it's very challenging. And see, now we're totally outside the realm of test estimation or even project estimation, best practices and theory and so forth, and we're off into psychology, as is so often the case with management. Erickson asks, Rex, is it easier to estimate tests in an Agile project? How to estimate tests running the requirements in parallel? Okay, so in Agile, it's easier in the sense that instead of trying to estimate for a 6-month or 12-month or 18-month period, you're estimating for a 2-week iteration or 4-week iteration. So that is going to be somewhat easier. But as you are pointing out, that the requirements can be changing as you're going along. I mean, they're not supposed to, but that does happen in Agile, even in spite of the Scrum dictate that the sprint content, once determined, should not be changed after the sprint started. What you're going to have to do if you are dealing with that situation where change is having an impact, is really make sure that at the very least people are getting religious about their burn down charts. So you can actually, if you're religious about the burn down charts, you'll actually force that dysfunction out into the open. Okay. We estimated that we were going to get through 40 story points in this 4-week iteration, but we only got through 25. That's our velocity. Next sprint, we are going to estimate for 25, right? And we're also going to do a retrospective to see how come we couldn't get more than that done. Why did we plan on 40 and we only got 25, right? But this does require a certain level of discipline, and it also gets back to what I was just talking about, of this Theory X versus Theory Y. You're only going to be able to do that kind of self-directed work if you're working in an organization that inherently has a Theory Y management philosophy at the upper levels. Scott says, this seems to mostly deal with new development. How would your suggestions fit with development that is custom functionality on a large-scale system, for example, ERP? Well, let's see. So These ideas that I've talked about should work for maintenance of existing systems, customization of existing systems, as well as development of new systems, and I've used them for both. There's some tweaking involved. So, for example, the when you're estimating the amount of testing to be done with customization, your ability to size based on developer days and so forth is undermined, because there's this whole question of the existing functionality that wasn't changed. How long will it take to test that? So the models have to be made a little more sophisticated. In that case, the historical data models, but the basic idea will still work. Beth says, I'm struggling with managers who want to estimate test execution time as a percentage of development time. Any good responses to this situation? Well, this is the infamous top-down estimation technique of the tester to developer ratio. It's the way that I would deal with it is to confront them with the reality that that doesn't work by showing them on past projects had the significant variation between what was predicted and what ended up happening. And especially if you can come up with some of these parametric models for, how long it takes to run every test once and how long it takes to get all the bugs out, you can say, look, using these models on these past projects, we would have predicted the actual outcome. Rather than this coarse-grained, non-parametric, well, it's somewhat parametric, but only in a very weak way, technique of just going, well, it takes 25% of the time to develop to get through the test execution, And sometimes that just becomes a self-fulfilling prophecy. We declare the testing done when the time is done. Well, in that case, then why not just say that it takes 1 day to test and declare it done after the day is done, right? If done bears no connection to having achieved a particular set of coverage goals and a particular level of quality, then done with testing can mean whatever anybody wants it to mean. Kind of a Alice in Wonderland thing there. Arshad says, should the planned estimations need to be revised and communicated to respective shareholders that the planned estimate are no longer valid due to certain reasons and propose revised estimates considering that instance, or push the team within the initial estimates to keep the promise? Well, if you can't get it done, you can't get it done, right? And definitely if external changes and circumstances have occurred that are impacting your ability to get it done, yeah, you need to take that to management and renegotiate the estimate. This throwing overtime at the problem to try to make people get something done after the estimate's been invalidated is just it's the easy out for a manager, because you don't have to get anybody's permission to do it. Usually it's that's sort of what people expect, but you will burn out and demotivate your team by doing that, and your best people will go somewhere else because they don't need that crap in their life. Bernard says, interesting and enlightening as usual. Thank you, Rex. You are quite welcome. Thanks for showing up. Chimera says, how do you estimate an unknown project that needs to be researched, like building one application to talk to another application that has never been done before? So the application has never been done, therefore there are no historical data to base on. Well, there's a few ways of approaching this, right? One is to use, kind of the classic one is to use what's called a spiral model, which is something that Barry Bain devised for defense projects that were very theoretical. And in the spiral model project, you do a sequence of experiments that are as short as you can possibly make them, and try to get all the big technical risks off the plate as quickly as you can. At that point, you've probably learned enough that you can actually estimate, okay, this is how much longer it's going to take. But The classic example of a project following the spiral model is the Strategic Defense Initiative. It's often mockingly referred to as Star Wars, which is the intercontinental ballistic missile intercept system that's being built in the United States. And I mean, that was proposed initially by Ronald Reagan in the mid 1980s. So, 30 years ago, and it still isn't done. On a more practical basis, you could do the same kind of thing with Agile, but just try to break the problem down into some bite-sized pieces, and starting with the most basic ones, do it in the first iteration, see what you've done. Basically, at that point, you've transformed Agile into a form of spiral methodology. And then you're only having to estimate one iteration at a time. The thing is that you can't predict how many iterations are going to be involved. Just like with the spiral model, you can't predict how many times you're going to have to iterate the spiral. Vlad asks, what are the best techniques to estimate impact of unknown factors, external tasks, tech support timing, etc.? Well, difficult. If these are things that have happened in the past, these external factors that have impacted you, you could always look and say, well, what is the typical loss rate associated with, external events like test environments going down and builds being late and so forth. But, it's, this is this whole black swan thing, right? It's very difficult to manage risks that you're completely unaware of. So, that's where we get into having some legitimate kind of contingency in your estimate. Is exactly that. It's to try to help you accommodate those things that you can't possibly be aware of. Jeremy asks, what's the key go-to for a greenfield site with no historical metrics or existing staff or experts? Okay, now that if you don't have historical metrics, I'd say pick up a copy of Jones's book, Estimating Software Costs, and you can use those industry numbers to at least sanity check some of what you're doing. Now, in terms of existing staff or experts, I mean, God, if you're doing a true greenfield project, then you want to get people who have been through this before. The ideal place for people to learn, software engineering practices and so forth is to be pulled into a team that's doing maintenance of existing code and just sort of, cut their teeth on that. Hopefully they've got some people there that can mentor them. But if you take a bunch of people who've never done something before and put them in a room and turn them loose, and try to estimate what's going to come out of that, you're going to get the occasional PayPal and Google and Uber, but more often than not, you're just going to get wasted time. It's going to be very difficult to estimate what's involved with that. Let's see. David says, we tend to do a high-level T-shirt estimate and then refine it as more information is made available. Is this an approach you estimate? Is this an approach you recommend also? We have clients that are doing that, yeah, so that certainly can work. If a tester is asked, this is Sandhya is asking this. If a tester is asked to do the test estimation instead of his manager / lead doing it, what are the best techniques the tester can apply for estimation? Basically, the techniques are the same. And this is one of the things that can be challenging about moving to an Agile environment is that now you're involved in doing estimation directly, and you might not have a lot of experience. So you need to learn some of these test management techniques. Let's see. Comment from Levi. Thanks, Rex. Awesome webinar. Always insightful. Kamara says, thank you very much. I have something to go by. Good. Bill says, thanks. This was informative and reminded me of what I knew at one time before 9 years at my current employer who dumbed down QA. I'm sorry to hear that. Let's see. Bernard asks, what is the difference in estimating a workload for testing per day and the adding of slack or padding to the workload evaluation? Well, the difference there is you actually have data to back that up. You go back and you look at, this is how many hours of test execution the tester can get done per day. So therefore, this is the time on task the tester is able to spend, and I'm using historical data to do that. I think a lot of times when people just add padding into these estimates, they're just kind of pulling a number out of the air, 25% or whatever, and I think more often than not, it's done as a defensive response against the management pushback that is inevitably going to come. Let's see. Ella mentioned that she had an audio drop, but then so that's only 2. So I'm thinking that that's just some glitches. Richard says, if you know a project has gone badly and large amounts of defects have been produced, would you include this data in the estimates or exclude it, assuming you have more data to base the estimate on? I'd definitely include it. Yep. I mean, if I think that there's going to be a larger than normal number of defects, and I think I can model that in my prediction, I'm definitely going to include it. Arshad, final question here from Arshad because we're running a little long. Says, what percentage of the test scripts that need to be considered for regression? As regression is usually calculated based on the number of issues reported in the earlier rounds of tests. However, I believe it should be measured through the area of impact and critical functions in it rather than rerunning the failed test scripts. Would like to understand your opinion on this. So, I mean, regression strategies vary quite a bit, Arshad. I mean, the brute force strategy, of course, is just to automate everything, and then every time anything changes, you rerun all of your automated tests. The problem with that is, there's some organizations can pull that off, and some of this is technology dependent, some of it's skill dependent in terms of the skills of the testers. But even organizations that can pull that off in the short run, like, for example, Microsoft did a lot of that, they found after a while that the number of tests became so fantastically huge that even though each test was run very fast, collectively it took a long time to get through all their tests. So that gets us to this question of test selection, which is really what you're getting to here, is like, how do I select the tests that need to be in my regression test suite? To just say it's a fixed percentage of the number of test cases, I think, to your point, ignores the fact that some changes are much more regression likely than others. So, it's an issue of identifying what's likely to break things and so forth. So, I would suggest you try to come up with a model that's a little bit more sophisticated. I mean, people like simple answers and just go, oh, well, we rerun all our tests, or we rerun 10% of our tests each time. Well, okay, you can do that, but there's to quote H.L. Mencken, for every complicated question there is a answer which is simple, obvious, and wrong. And I think a lot of that does go on in estimation, is that people go for the simple, obvious but wrong answer just because it's simple and obvious. So, good idea to avoid that. All right, we've run a little long, so I'm going to need to close it down. To close the session, a little bit more about the resources available through RBCS. We run these free webinar sessions once a month, so please check our website, rbcs-us.com, to sign up. If you'd like a special webinar presentation for your company only of this webinar or any other topic related to software testing, email us at info@rbcs-us.com or via our website. If you don't already receive our regular newsletter, free newsletter, sign up at rbcs-us.com. By signing up, you'll get valuable discounts on training and consulting services, along with a regular newsletter that includes a featured article on software testing and quality and news about what RBCS and its partners are doing lately. You can also follow us at Twitter, It's at RBCS, and we're on Facebook, RBCS-INC. Do check your email over the next couple days. You might be the lucky winner of a free e-learning course from RBCS. You are registered for the random drawing of this course simply by attending this free webinar. Make sure to check out our digital library, too, recordings of these webinars, podcasts, and videos. We have an RSS feed on our website, which will allow you to automatically receive podcasts when they are published once a month. We offer these free resources as a service to the software testing community because at RBCS, we are a not-just-for-profit company. This concludes the webinar. Thanks to everyone for joining us today. Look forward to seeing you next year.